Hi, welcome to my presentation. My name is Mateo Arroyo from Christian Liberty Academy 7th grade. I am going to be talking about how the parachute surface area affects the descending rate. I chose this experiment because I was curious to see if in fact the smallest parachute will land first than the bigger ones. My curiosity peaked after watching an old war movie and realized the importance of parachutes. My hypothesis was that if I dropped different sized parachutes, the smallest parachute would hit the ground first. But before I share my experiment results, I would like to talk about the parachute itself and its history. Equipment in war and peace for safely dropping supplies and equipment and people, and they are developed for slowing or returning space capsule after re-entry. And according to my research, the word parachute comes from the French word parer, which means to guard and shoot, meaning fall safely down, making sure you are safe. Parachutes allow a person or an object attached to it fall down vertically in slow motion through an atmosphere by creating drag force track. Supposedly, the parachute was created by the Chinese emperor who jumped from a burning building, making his escape successfully. Then the Arabs and other inventors wanted credit. However, the actual five inventors that contributed in history regarding the parachute were: number one, Leonardo da Vinci, also known as father of the parachute, who sketched pyramidal tent roof designs but was not ever tested. Then number two, Fausto Verragio, also known as the Flying Man, who was inspired by Da Vinci's sketches and eventually drew his own as a parfoil-shaped parachute canopy. Number three, Louis Sebastian Lenormand, who invented the actual Le Parachute. He jumped from a tree with the help of two modified umbrellas, and later in 1783 he made the first recorded successful parachute jump, clinging to a 14-foot cloth parachute with a rigid wooden frame. He stepped off the top of the Montpellier Observatory and did not get hurt. Number four, Jean-Pierre Blanchard. He discovered that silk is good for parachutes. And finally, Andreas Jacques Gardnerin, who perfected the parachute and made jumps from greater altitudes. In today's day, parachutes have fought winds and poor Earth's atmosphere. They are also used in the sport of skydiving. As for my experiment, I ran my experiment by making four different sized circular parachute canopies hand from plastic sheets, and I then cut four strings for each parachute and glued them to each parachute canopies. Each length equals the diameter of the parachute canopy. Then I added an army figurine to each parachute, then raised each parachute from a height of 5 meters and dropped to the ground, and recorded the time data. I repeated these steps for each parachute individually 4 times. The independent variable was the size of the parachute. It was the only variable that I changed. The dependent variable was the time that the parachute falls. All the parachutes were made out of plastic circular with the same army figurine weight, and dropped down for each parachute. As for error analysis, I ran my experiment in a couple of times because it was either very sunny or very windy or it would start raining. In conclusion, as you can see, my chart and graph support my hypothesis that the bigger the parachute, the longer it will take to land with gravity and winds impacting the parachute. The drop time of the parachute is the time taken by the parachute to drop from a high level to the ground. The drop time of parachutes is affected by factors such as canopy, payload, ventole, and suspension lines. Thank you for your time. God bless you.